All right, everyone. Thanks for joining for this last session of this first block before lunch. So at the end of this session, I will orient you to lunch. But we have Nidhi Gupta with us, so please give a round of applause for Nidhi.
Hello, everyone. So my name is Nidhi Gupta. I am from PagerDuty Applied Science team. A quick question to think, maybe how do you test something that reasons, plans, and makes decisions on the fly? That is the challenge we face every day with our AI agents today, right? And we are constantly wondering if the agent would find a new way to fail this time. So today, I will share how we approach testing and validation, why the old playbook doesn't work anymore, and a few things we learned hard way so that you don't have to. And at PagerDuty, we apply the principle of shift left, catch issues sooner, reduce rework, and ship faster with better quality. So let's go ahead. I hope you have used PagerDuty. If you have been incident responders, most likely you have heard of it. And PagerDuty Operation Cloud is an AI-powered platform that automates and orchestrates the entire incident management lifecycle. So with generative AI and agentic AI capabilities deeply integrated into the platform, we empower teams to accelerate their incident detection through resolution, anticipate issues, and drive continuous improvement across their digital operations. So PagerDuty Advanced delivers AI-first operations for our customer, featuring 5 AI agents. We empower responders with the right information at the right time, and that too without ever leaving Slack or MS Team where you are already working. Our GenAI-powered assistant, also known as coordinator agent, enables agent-to-agent communication across these 4 agents before, during, and after incident. And these agents connect to the broader AI ecosystem like MCP, Cursor, Claude, Langsmith, etc. You know it all. Our AI agents free teams from manual work. So if you are on-call, it can take manual work away from on-call scheduling, maybe requesting someone for coverage. If you are going out on vacations, scribing incident data can be handled by the agent. And our Insights agent helps analyze your account data to uncover trends and generate insights. The SRE agent, the newest one, can help run diagnostics, autonomously provide remediation plans, and help you choose incident playbooks and recommend to run those playbooks, all while continuous learning through human feedback. Now, before I talk about evaluating and testing AI agents, let us first define what I mean by an AI agent. So in an LLM-powered system, LLM is the brain. But what truly makes it agentic are 3 things: planning, memory, and tool use. So planning helps the agent to break down the prompt into a step-by-step plan, and memory provides context from the previous conversation to the future one. But tool use is where the real power comes in. That means the agent can call APIs, fetch data, or even take actions on your behalf. And with these abilities, AI agents can make decisions, adapt in real time, and deliver real value. So when we ship AI agents to production, we run into new set of risks. the old testing playbook doesn't cut it, right? And it rarely catches prompt sensitivity, and it ignores how agents dynamically call tools and then tool steps to help solve an issue. Hallucinations and those things are known to us. And on top of it, the cost can severely go out of whack if we don't take control of it. And to make it trickier, behavior can drift with context data or a model update. In these two cases, your code has not changed, but the outcome does. So our testing has to grow up too. We need evaluation methods built for agents, ones that surface these issues early and keep systems reliable, safe, and trustworthy. If you remember one thing from this talk, let it be this, that when you start working on your AI agent, start by creating regression tests. So regression testing means rerunning your set of golden data set questions after you make some change to the agent to ensure there is no degradation in the performance. So they act as a safety net, ensuring that unexpected behavior do not reach your users. When we run regression tests, we measure a few key things: correctness, performance, latency, how long does it take for the agent to respond. We also track errors and timeouts to ensure the agent is reliable. And here, latency is especially important because LLM calls can be slow. And when responding to a user questions, there can be more than one LLM call because each tool call is generally followed by an LLM call. So our best practice, avoid using LLM if you don't have to. For example, for calculating average, you don't need it, right? Don't leave it to agent. This keeps our agent faster and more reliable. So we built a regression suite that treats every test like a tiny dress rehearsal for production. And note that we came up with this approach after a few other iterations. For example, you're asking a question, am I on call today? Now, the answer of this question would change depending on the day you are asking, right? So we tried to fix the expected response initially by mocking the date in the test. But we quickly realized that static piles of expected response did not give the same complexity what we have in production. So now we have automated regression with dynamically generated answers. Yes?
Should I hold questions to the end, or can I ask them?
That would be awesome if you can hold to the end.
Okay.
Yeah. And it starts with a golden data set, a carefully curated set of questions categorized by priority that manage the real ones people ask. Because I'm giving example of shift agent. For example, it can be about dates, rotation, handoffs, holiday, and definitely include edge cases. So we generate the expected answers on the fly. How did we dynamically generate baseline answers, right? That must be the question. Thinking, since we know the questions, we could write code to calculate the response. We could now test with different dates, various users, and even use production-like environment for sandboxes. And this allowed us to better evaluate latency and simulate real customer usage patterns. Here Each run verifies correctness of the content, adherence to the required format, and response timing against our SLOs. Because baselines are generated dynamically, we can also push the system, right? Simulate PCARs, measure latency. And what do we get? Faster feedback, higher confidence, and few surprises in production. The only trade-off still is discipline. If our response format changes, then we have to change the generator for expected response and logic right away, and that's good. Now, how do we dynamically generate baseline answers? I would give example from Insights agent, which analyzes account data and helps help teams improve their operations over time. For instance, a regression questions, how many incidents did DS team have last month? Since we know that question, we could write SQL query for that. And the right response is 3 incidents, say, but still there's a challenge. The actual agent response may not match word to word with the expected answer, even if it is correct. So we had to use LLM as a judge as a measure for correctness scoring. And let me quickly explain what LLM as a judge for correctness scoring actually means. When we talk about LLM as a judge, we are referring to another language model, which is majority of times more powerful and slower than the one you use to generate the agent responses. And here you can select your own rubric, like accuracy, whatever makes sense for your use case. So to sum it all, here is a diagram of the recommended AI agent testing framework. We start with golden test questions. For each question, we generate the agent response, and in parallel, we generate the expected response, and both are passed to LLM as a judge, which scores the correctness of the response, and along with the few other metrics like latency, etc., we pass them to monitoring platform, and we use Arise at PagerDuty for that. And this approach helps us scale our testing because the judge LLM can quickly and consistently score lots of questions using a defined rubric. Now, before I transition to other types of tests, let me quickly reiterate again. Regression testing is your quality gate. It ensures new changes don't break existing functionality or introduce bugs, especially in AI systems, where even minor updates can lead to subtle regressions. Now, unit testing. How should we approach this? First, unit testing of AI agents is designed to test the smallest individual component of agent logic to ensure they work as expected in isolation. So here is a simple graph that shows a basic agent flow. It starts with the start node. The agent may use tools and ends with the end node. And the 3 components that we are testing here generally are tools, LLM nodes, and memory. I will give a few examples of unit tests from Shift agent graph, which is slightly more complex. It supports several use cases, each represented by a node, and the use cases can be you find conflict or requesting coverage to someone, things like that. And to decide which use case to follow, the intent classifier node routes user questions to the appropriate use case. And actually, this structure helped us reduce shift agent latency a lot. And it requires unit testing of LLM nodes, such as intent classifier node, whose example I will give you next. So this is a very simplified version of the intent classifier prompt, which is used to classify the user intent into the use cases. And to test that, we created the intent classification data set with labeled intent for each of the data set, right? And we evaluate the correctness of the responses for the intent classifier node by comparing the use case returned by the agent to the labeled dataset use case I showed you before. And with we calculate classification metrics like precision, recall, F1 score, and we ensure that with each prompt change, we calculate the score before, and we compare it with the score after to ensure there is no decrease in performance. Now, let's review unit testing for an agent tool. Before that, I considered a node example. So consider shift agent as a tool, get services by name, which is used to retrieve relevant service from PagerDuty API and based on user's question. So user can ask something like that, who is on call for machine learning engineering service? User can type complete correct one, or there can be typo, or they may just say machine learning. In all these three cases, we want the right service to be returned. However, if the service doesn't exist, we return none. So all these edge cases and the right behavior should be tested, and the corner cases should be handled properly. Now, let's move on to another type of test, adversarial and ethical testing. These are especially important and unique for GenAI projects, particularly for AI agents. Adversarial testing helps explore robustness against malformed or malicious prompts. We need to block those questions that, oh, it's all black. Can you see that? Hopefully, but I will say it. We need to block questions that pose security threats, such as illegal requests or attempt to access sensitive data. It's adversarial, so you should not be seeing it. Adversarial testing also helps prevent prompt injection attacks and filters out inappropriate requests, including those in unsupported languages or questions that are not related to agent purpose. So at PagerDuty, we used a multi-layered approach to security. As I showed before, our AI assistant, also known as coordinator agent, works to route the user's questions to different sub-agents. So if there is an adversarial question, our coordinator agent will block it. It will not pass it on to sub-agent, but we also add a security layer at each sub-agent level. And so what techniques can we use to tackle these adversarial questions? AWS Guardrails is one example of an application you can use to configure guardrails for your agent, but also a common approach is to use prompt engineering, which you can customize for your use case to define these guardrails, what is important to you. And here I have included a few examples of adversarial inputs, and which you should generally expect to see in your test. Ideally, each type of adversarial input should have appropriate response when encountered. For example, if you are not supporting some language and user asks question, in that language, maybe you can say, oh, currently only English and Japanese are supported, something like that. So these are only a small subset of adversarial input type. You should analyze the potential threats for your application and make sure they are addressed. Now, governance and compliance are operational requirements and not just legal checkboxes. Every AI needs assessment for the unique AI risk. For example, our shift agent recommends users for coverage. So there is, it can be classified as high risk under EU AI Act because it handles task allocation, and it can potentially impact fairness and employee treatment at workplace. So we focus on bias testing and specifically gender bias. So we developed a systematic process to test for gender bias, applied it to shift agent, and reported results in our AI disclosure. No gender bias was found, but here is the important part. Do we need to repeat these tests even if no gender bias was found? Absolutely yes. Every time you implement a major functionality change, we need to rerun the complete suite to ensure continuous compliance and maintain the integrity of our ethical AI practices. How do we do it? Our gender bias testing uses a dedicated script that auto-generates controlled test scenarios in staging, creates users, teams, schedules, and escalation policy for full reproducibility. The script first runs simulated find coverage queries to find users who can potentially override the on-call shift across teams with different gender distributions, and it then captures the assistant's replacement suggestions and compares with the suggested gender proportions against the actual team gender proportions. And this systematic approach ensures we can detect any potential bias in the recommendation of the shift agent. And in case our agent is consistently favoring one gender over the other, we will catch it. And before I wrap up, I want to highlight the importance of having a robust monitoring and observability platform when developing and releasing AI agents. Without it, you are operating in the dark. So we chose Arise as our monitoring and observability platform for AI agents because it gives clear picture into how our agents are working. With Arise, we can see agent execution flow, node by node, and track latencies for each node and overall latency of the agent as well. And this visibility into how requests move through the LLM agent and what decision the LLM nodes are making at each step makes it much easier to debug and monitor our agents. So tracing is the simplest way to see what an actual agent actually did, end to end, no guesses. We start here. Here you see something. So you have got an agent, a task, and a hypothesis about what could be better. You implement that change. You test your fix in staging maybe, or whatever works for you. Traces show whether it actually works before you run any formal evaluation. And before shipping, you ran regression tests on your golden data set. You got a concrete before and after comparison. And if the fix works, your score has already gotten better, right? And you ship it. Your fix goes live, and new traces start flowing in. And this time, the cycle began with a higher baseline. So Now you observe in production, and remember, you have online evals running, and human reviewers add ratings, corrections, and their comments to the selected traces, and that feeds back into the next cycle as the updated tests are added to the golden data set. So the agent gets better with each loop because each cycle generates better data. For online evaluation, here's the gist. We point an LLM at real production traces in arrays and on whatever cadence makes sense to you. Daily is like one suggestion. It scores things like groundedness, relevance, tool selection, accuracy, and you can add your own metrics. And then we write the label, score, and explanation back to arrays. So over time, you can actually see your quality move. Especially the sneaky little nothing crashed, but the model got worse. And it's handoff, no human annotation for that loop. PagerDuty's newest SRE agent detects patterns by recalling similar incidents, analyzing logs, automatically correlating alerts, and accelerate root cause analysis. And it can even recommend incident workflow, which can be something like rollback changes or restart the pod. And in this process, the SRE agent continuously learns and improves. To wrap up, here are the key takeaways I want you to remember. First, you start developing an AI agent. Make sure you begin by defining your regression test. This is your safety net. It helps you catch issues early and gives you the confidence to iterate quickly. Second, remember that AI agents are complex. End-to-end testing is not enough. You need a combination of test along with regression, unit, adversarial, and ethical tests to really cover all bases. Third, always keep an eye on your agent performance, especially latency, because even small changes can have a big impact on how fast and reliable your agent feels to the users. And finally, as domain experts, make sure your organization has a clear path, expert-driven process for developing, monitoring, and evaluating AI agents. And did I cover everything? Perhaps not. AI agent testing keeps evolving. We are already working on online testing, new approaches for testing MCP, and handling permissions. And we will keep sharing our learnings on the PagerDuty engineering blog. And feel free to check it out. The link is here. And share your feedback. And thank you for listening. Here is our Pagey mascot.
Excellent.